This is a short video explaining how to find the stationary points of a curve by completing the square. So first off, what exactly is a stationary point? So for example, if I had a quadratic graph that looked just like this, the stationary point is the point where the gradient is 0, exactly at this point down here. In order to find the stationary point of a quadratic graph, we first must complete the square on the quadratic equation. So say I had the quadratic equation x squared plus 6x minus 2, and that's the curve I want to find the stationary point of. In order to complete the square, you want to find the quadratic equation and put it into the form of this: x plus a all squared plus or minus b. So you need to turn this equation into the same thing but looking like this. And the best way to do this is to start off by only considering this part of the equation here. And what we're going to do is we're going to try and make it look like this part of the completed the square version of this equation. And to do that, we first start off by halving this middle number here. So we put it into the brackets like so, and it's already starting to look a lot like this one over here. And we square it just like in here. So that's looking a lot like that at the moment. But if we expand this out like so, we find that we get this extra 9 over here, which we don't want in our equation. We just want the x squared plus 6. So what we do is we subtract the 9 from this x plus 3 all squared, leaving us with this. And that here is equal to this first part in red. But we've left out this minus 2 here, which still needs to be dealt with. So we write it all out again. Minus 9, minus 2. So now this here is equal to our original equation. So if we simplify it down a bit, we've now found the completed the square form of this initial quadratic equation. So how does this help us in finding the stationary point of a quadratic graph? Well, these numbers here correspond to the x and y coordinates respectively of the stationary point, except the sign of the x coordinate within the bracket needs to be flipped. So we inverse the sign. So the stationary point of this first curve up here is minus 3 minus 11 with x and y. Let's try another example. So say we have the quadratic equation x squared plus 10x plus 3, and we want to put that in the form again x plus a all squared plus or minus b. So first off, again, we just want to focus on the first part of the equation and trying to make it look like this over here. So again, we halve the middle number and put it in the bracket. And then we expand it out to find out what we need to subtract from it to make it equal to the first bit of the equation. So in this case, we've ended up with this extra plus 25, which we need to subtract from the original bracket. Then again, we get this 3 and we add it on to the end. Leaving us with x plus 5 all squared minus 22. And that is the completed the square form of this equation up here. So again, let's get the stationary point coordinates. We flip the sign of the number that's in the x, within the bracket, sorry, So the stationary point is minus 5 minus 22. You do not flip the sign of the y coordinate, which is outside the bracket. Let's try another example again. So this time we'll have the quadratic equation x squared plus 4x minus 12. And that needs to be put into form a at x plus a all squared plus or minus b. Again, we'll just take the first 2/3 of the quadratic equation and we'll halve the middle number and put it into the brackets. Then we expand it out and realise we've got this plus 4, which needs to be removed from this bracket, this sort of bracket thing, in order to make it equal to this first half here. So we have x plus 2 all squared minus 4. Then we need to account for this minus 12 up here again, so we have x plus 2 all squared minus 4 minus 12, and that leaves us with the completed square form of x plus 2 all squared minus 16. With the stationary point of this curve being minus 2 minus 16.